Everyone. I hope we are live now. I think we are. Welcome to Memgraph Community Call. Today I have Dino from EBCONT and Ante from Memgraph, as his t-shirt says, with us. So thank you both for joining. Thank you for agreeing to doing this presentation. The topic is from pixels to knowledge, but I'm not going to talk in details about that just because they have a pretty good introduction and I don't want to mess with that. Uh, but just maybe from my perspective, I attended Weblitza conference recently and saw them doing a similar presentation and demo, and I thought it would be really cool to share this with the wider community of Memgraph so that everyone could see it. It's a really nice demo. Hopefully it will work as it's a live demo. Fingers crossed for you guys. And I think that's it regarding the introduction and just a small information. So we have a chat here in Crowdcast, so you can ask questions there or maybe even better in the Q&A section. So we will read them out loud after the presentation in the Q&A section, and then Ante and Dino will be able to answer them. There will be a couple of polls posted by Matea, my teammate, as well. It's in another tab in Crowdcast. And I think that's it. Let me know if anything is unclear in the chat. I will be there lurking around. And Ante and Dino, the floor is yours.
Thanks, Katarina. Let me just share my screen. Oh, not turn on the camera. Turn on the camera. And screen. Screen 2. Look like good. Yep. Cool. Hi once again. This, as Katarina said, this presentation and this demo that we're going to show started as a collaboration between EBCONT and Memgraph. We were discussing on going to some conference together and working together on different projects. And then Bruno from EBCONT, Dino, and me had this idea about mixing the pixels and the graph and the computer vision, which was kind of the weird mix. And initially I was like, what are we going to do with this? But in the end, it was very fun. It was funny, and it turned out to be an interesting use case. And then we kind of decided that we'll go with that idea and kind of build a demo. And yeah, it turned out great. So I'm happy that we are going to have a chance to share this with you. So today's topic is from pixels to knowledge. Before going further, a brief intro. So, hi, I'm Ante. I work as the DX engineer in Memgraph. I guess at some point, most of you had a chance to talk to me, in some Discord or related communication channels in Memgraph. And yeah, I'm letting Dino to do the intro. Dino, you
Hi
need to
everyone.
unmute yourself.
Yeah.
Cool.
Hi everyone. I'm Dino. I come from Austria and I work as a senior IT consultant at EBCONT. Who is EBCONT? So EBCONT is an Austrian-based IT company with over 25 years of experience in delivering software solutions. We employ over 700 professionals and we support more than 120 clients across various industries and all over the world. We operate offices in Austria, Croatia, Germany, and United States. While our roots lie in Java development, we now offer full cycle software development across a wide range of modern technologies and frameworks, including Java, .NET, Angular, React, and many more. EBCONT is structured into 4 specialized units. Enterprise focuses on end-to-end software development. ProConsult specializes in project management, requirements engineering, and business analysis. Communication delivers expertise in UI, UX design, prototyping, and user-centered solutions. And last but not least, EBCONT operations ensures smooth application deployment and maintenance in the cloud and with comprehensive DevOps support.
Cool. So as we kind of started working on this, I'm today going to do the part on the presentation side, and I'll present you the idea and how we think about this and how we build this and what is kind of the structure of this application. It's a POC type of thing. And Dino will later show you how the demo actually works from operational perspective and how it returns results. You'll see. And in the end, we'll be happy to answer the question. So what are we going to talk about? We're going to talk about 4 different topics. It's about understanding the images, which is like a computer vision approach. Then we're going to talk about how to search the images. Then we're going to talk about the knowledge graph. And then we are going to show that demo. So the presentation is kind of just to get you into the demo and to kind of center you about the idea that we had. And then in demo, we'll see like how it all works. So obviously, images are super cool resource, and we are kind of trying to understand the images. Memgraph maybe doesn't sound like a great thing to store images in, which is somewhat true. But there are ways that you can enhance your image search via Memgraph, and one of the fun things as a result of this demo is essentially that. So before we dive into the search, let's focus on understanding the images. So if I now ask you all, like, what is on this image, I guess different ideas come to mind. So, for example, you may think about the garbage bin behind, the doors, the yellow car, the panel windows behind. But essentially, here is yellow car, which is type of rail and regal, and it is from a very popular British sitcom, Only Fools and Horses. But essentially, any person that kind of takes a look at this can see what is this about, and immediately you get the understanding from just looking at the image. So we as a human have this like good processing power between our ears that is called the brain, and our neural net can handle this information very, very good. And this is the years of evolution that we have in our brain. It kind of enables us to kind of interpret all the text, the objects, how they're structured on the scene, what colors they are, and we can kind of fully understand what is on the picture. So if you're going to answer like what is on the image, we could say like a bunch of stuff there. Like this shows yellow three-wheeled vans that look like iconic vehicle from the British sitcom Only Fools and Horses, which is a great sitcom if you didn't watch it. Now, what is on this image? So if you now ask like a machine to do it, it wouldn't immediately know what is on the image. Now, depending on what computer vision pipeline you're running, it may understand that this is a cat. But essentially, the computers can see an images as a matrices, and then you have like a green, the red, and blue aspects of each pixel, and each pixel represents some intensity in the given channel. If you're talking about images in color, if you're talking about grayscale images, then we have just the intensity. What is important is the machines do not understand the image as we humans do instantly, so we need to build some computer vision pipelines to actually understand that. An example would be if you have like a traffic image or a car image. Here, for example, you have like multiple cars and multiple people walking on the crossroad. Then what you could do is like something called semantic segmentation, which essentially segments the image pixels into the objects that are semantically similar. That's the reason why, for example, cars are in the blue color, the whole road is purple, then the pathway is pinkish, and the folks are red, and the rest of the image. And then from semantic segmentation, you can do an instant segmentation, which is, okay, so I have the cars, they share the same semantic meaning to the image, like we have different cars on that image, so what brand they are, what type they are, etc. So this is a deeper level processing. Now the third part could be kind of mix it together to panoptic segmentation, which kind of meshes these two things into concrete part, and then you have like semantic segmentation and instance segmentation together, and this gives you some kind of structured information about the image. So we won't go deep dive into the computer vision processing algorithms and how the computer vision processing part works. I just wanted to paint a picture that we as a human have that understanding. Computer doesn't have that understanding, and we can kind of use different algorithms to essentially get to that structured understanding. What we are more focused on, as Memgraph is kind of the database company, is about how to essentially search those images. And as I said, images contain rich, unstructured data. If you open your phone gallery, you will see a bunch of different images that are kind of not very correlated. And then turning those images into knowledge essentially enables you to do a better search, to do some recommendation, questions answering. And NLP seems like a super practical solution to do it. So imagine yourself kind of asking different questions about your own personal gallery. Now, if you think about that, it's not that it's a new idea. So essentially the Photos app in your iPhone, if you have to open Photos and if you have like the latest version of iOS, they essentially added something similar to that in a recent couple of releases. I'm not sure what year was that, like maybe last year. So essentially, you can open a Photos app on your iPhone and ask, for example, a car, or you can write a motorbike, or a bike, or a dog. And photo gallery should return all the results that kind of correlate with the name dog or text dog. So in these two images, you can see an example. So for example, you can search like scooter in 2024, or like Stirling, which is a pet name given in the Photos app. So essentially, searching Photos app in NLP seems like a super practical thing to do. And we wanted to see like how we can enable this experience in Memgraph. So there is one kind of key component here. It's a CLIPI, which is stands for Constructive Language Image Pre-training. It was developed by OpenAI in 2022. Essentially, what it does, it converts images and text into comparable embeddings. What that means is that they use the text encoders and image encoders to create a common matrix of embeddings, which enables them to go back and forth between the text and images. So essentially, this means that you can mix and match images and NLP, but what is even more cool is that you have this zero-shot understanding. What that means is that typically computer vision pipelines that were used in were limited to a set of objects that neural nets can recognize. So most of the neural nets can only understand the classes that were trained on, and then they cannot understand something outside of that scope. Zero-shot understanding essentially enables you to give some output, no matter the object that came, and it will have some understanding given the text or an image. So essentially, when you kind of do that zero-shot prediction, you have image encoder that then leads to output a photo of a dog, which was based on the text encoder that was pre-trained on. So essentially, like mixing the two together. Why it's important? Two key features. It let us compare a car image to another car image, or a car image to a natural language query. It's essentially like a bridge between the visual data and language-driven reasoning. So in our example, it's like a red sport car with aggressive styling, and then the same image of that car live in the same embedding space, which in a practical sense means that you can search the image via NLP or via the image. So now how the whole knowledge graph type of thing kind of fits into this picture. So imagine that there is data that is very important to you, and you still want to have the search on top of the data, and you don't want to have like fuzzy results in terms of like where the vector will land in that embedding space and then kind of land on the different results. You rather want to have the key pieces of data built in the knowledge graph, which will be a backbone for serving the results together with the vector search. So we decided to build that car knowledge graph. We extracted the key information to build the structured data from the car images. In our case, those are like the car that has some properties, then the car has a color, then the car was made by the manufacturer, then the car has that particular body type. Now, this knowledge graph is super simple. It could grow. So, for example, we can kind of look at where the car was registered, what type of car it is it electric, is it a hybrid? We could look at like different properties that could be kind of molded into this knowledge graph. And essentially, this provides us with a base for searching the knowledge graph. It just depends on like what type of information we want to extract. Now, once we have that knowledge graph, we essentially have like a graph through to support a GraphRAG system on top of it. So essentially, we can search the images via the NLP query, which is then like represents something like a GraphRAG system on top of images. Dino will show how that all works in a bit. So essentially, what we do from a practical standpoint is we take a bunch of car images. We use Gemini API to extract the data from the image, put it into JSON format, and then create a Cypher query out of it. So the JSON format is essentially how we are building this knowledge graph. Then, parallel to that, we use Clippy to create an embedding and store each embedding on each car node. So we have an access to that particular car node in the knowledge graph. Then we mesh it all in the Cypher and store that into the Memgraph. And this gives us an opportunity to essentially search this via two different approaches. And in a typical like GraphRAG scenario, where users ask some question, like you would ask your photo app gallery, give me all my tennis sessions. Like you will expect it to return the images of your tennis session, or give me all the images of a car that I have in my photo app, and you will expect it to return all the results that have a car in it. But then you can also ask like, give me all the cars that have the yellow color in it, and then the question is like how it will return these results. And this is where essentially the GraphRAG and knowledge graph type of thing comes in. It's how you are searching the data. And one of the key points here, if you have that knowledge graph underneath the hood, is you ask a question. Now that question is being embedded and compared to the images, and you're using an image as a pivot point. So essentially, if I'm asking about a blue car or a yellow car, I want to land on that particular car. And then when I find that blue car, then from there, I want to do a relevance expansion to fetch all the relevant data around that car. So kind of we have the key point and then the relevant data around that car. That could be interesting to answer the question. We then feed those relevant results to user question and pass this forward to the LLM to provide an answer. Did we like find the cars and what cars are there in the image, etc. Yeah, this is all from like a theoretical perspective. And now Dino can take over and show you the demo.
Thank you, Ante. So I hope you see my screen now.
Yeah, looks good.
Okay, cool. So in this demo part, we have three things that we want to show you. I will start with the image processing and storage. So basically in this part, we will show you how we everything that Ante talked about, and how we process the image, how we extract the data from the image, and how we store it in the Memgraph. So basically, we have to select the image here that we want to upload. I previously uploaded all these images except these two, and I will upload one of them now because it is the same car, and we will see what happens. As you can see, the image is processed by the Gemini, and Gemini then extracts some physical features from the image, like car model, year, dimensions, some brief description, color, body type, and manufacturer data. The next step is to represent this image as a vector using the clip model that Ante previously mentioned. And then the next step is to store this data in the Memgraph by writing some simple cipher queries and creating manufacturer node, car node, color and body type node, and relationships between them. What is interesting for later is that we save this vector into the car embedding property. And the last step, just to show what we did with these queries, is to show the results of the cipher queries. So as I mentioned, I won't upload any more images because I previously did that. So let's now show the image query part where we will try to find this car by some other image. As you can see, this car is exactly the same one, just from another angle. And we want to find, we want to see if we already have it in the database or if we have the similar one in the database. The process is same as storing the data in the Memgraph. We have to create embedding again, and then we have to perform a vector search in Memgraph. And as you can see, we get top 3 results from the Memgraph. And as you can see, this is already a pretty good indication that we found the right car. Oh, I actually already uploaded this car before. But as you can see, we got exactly the same image, which means that the image query worked. We can also try searching for another image, maybe this one that I wanted to find previously. And as you can see, we found the exactly same image. Now the third part is text query, where you can basically ask by using English what is stored in the database. So for example, we can ask, is there a yellow car in the dataset? And let's see what the answer is. Again, the process is the same. We convert this string to the vector representation using clip model, and then we do the vector search in Memgraph, and there we have top 3 results again. And this is the image. This is the most similar image to the question that we asked. So now that we have this car and this image, we want to get more data around it. We want to get relevant data around this node, this car. So we get all this kind of information, and we provide that information. Since this is really hard for normal people to read and to understand, we will send this raw data to the Gemini, with the user question, and Gemini will then answer us, yes, there is a yellow car in the database. Several entries include the relationship has color with the value yellow. So now we can, for example, ask which yellow cars do we have in dataset? And it should list us the actual models of the cars that we have in the database. The following cars are yellow, Zastava on Reliant Regal, the one that Ante previously mentioned in the presentations. How this actually works, I would like to show it in the code. So basically, we need to input text query, then we have to run text query.
Just a second, Dino. Yeah, I think that you're not sharing. Yeah.
Yeah. One moment, I will switch the screens. Is it okay now?
Yeah, can you just zoom it in a bit?
Yeah. Okay.
Yeah, looks great.
So basically, we have a text query, the input field, and we have we submit that input, and we convert it to the vector, as I mentioned previously. Then we want to, with this vector, we want to perform a vector search on car embedding index. And we can do that easily with just this small query in Memgraph. So basically this searches the index that we provided, and we say we want top 3 results back. And then when we get these top 3 results, we want the first one. Why first one? Because it's the most similar to our text prompt. And then we want to get the relevant data around that image. We do that by calling following query. And when we get the relevant data, this big JSON object that I showed you previously, we provide that to the Gemini with the text query and the data. And then Gemini is able to answer the question properly. With that, I conclude my presentation. Is there any questions?
Thank you, Dino. So currently there aren't any questions. So if anyone has any, please post them in the Q&A section. But I have a question, of course, for you guys. So can you maybe reiterate on why exactly are you using a graph database? That is, if we had, for example, a vector database and store everything in it and do the app like a lot of people are now doing, like what is the difference there? And can you give me like an example of why that wouldn't work well or would to explain to the viewers?
Yeah, so if you like use the vector database to do something similar, you could do it. So for example, the vector search would vector image search would work as is in Memgraph, because in this pipeline we only did like a vector search. Then on the second example with the NLP, what is powerful there is that once we land on that particular node that is very interesting to us via the NLP query, we essentially fetch the relevant data that is around that node. And the data around that node, which was in this case a yellow car, has other yellow cars related to him. So essentially, for example, if you ask for a yellow pickup truck, that means if you land on a yellow pickup trucks, the rest of the yellow pickup trucks would be also correlated there, because you have that body type relationship going from that car. You have a color relation going from that car. Then you have like a manufacturer relation going from that car. And you have like this very dense knowledge about that car that is correlated to other cars. And this is what you wouldn't get from a vector. From a vector, you would get like a yellow car as a first result, and then maybe a green car as a second result, and you would still get a good first result. But the question is, when you ask like Dino asked, like, what are the all yellow cars in the data set? Now that's the question: would you get like all the yellow cars as the result, as a top result in that vector search? As you kind of start adding more parameters to that embedding, the question is, would the vector database, for example, respond the right way? So you're kind of the grounding the LLM around that key knowledge that is around that node.
And could you ask like any type of question, because now you have asked some questions and you are aware of the data model that's in the background, like what affects which, like do you first model the data, then figure out the questions? Is it important to know the model? Like how you think about that, like questions that you can ask within your app versus the data model that you have in the background?
Yeah, I mean, that's also important because as you're modeling the graph, you need to reconsider like what type of questions you're going to ask, and this also brings that, like, if you are modeling a body type as a part of a property, then maybe you wouldn't get all the related cars that have a similar property. Rather, you will have like copies on each node. And the question is like, how are those nodes connected? But if you pull that body type or a color, for example, as a separate node, and then the rest of the node is connected via that relationship, that means that you can fetch all the rest of the cars that are also yellow, which gives you like that pivot point around you can search for the similar nodes. So yeah, to answer the question, yeah, that part is also important. But Dino can also ask like different questions, either like a BMW, what BMW are there. The important part is that you land on some type of BMW first, and once you're on that BMW, you can kind of go wherever you want because the graph is structured that way. And we have like that very generic query, which is essentially just like doing those two hops, which means that we don't depend on the graph schema at all. So essentially, whatever kind of goes into that graph and that is related to hops from that car, we can fetch it.
Yeah, question related to that from the audience. So would it be accurate to say that a knowledge graph allows results that are further than one step relationships when querying for something?
So would it be accurate to say that knowledge graphs allow results that are further than one? Yes, exactly. Yeah. Yeah. And the knowledge around the particular node that kind of pops up from a vector search is usually the most valuable knowledge, because that's the key winner that you want. Or you could say like fetch the top 3 results from a vector search and then fetch some data around them, because those are like 3 key points. But that ability to fetch data that is connected to it is like a value of the graph.
Okay, Dina, did you want to show something?
Yeah,
there was another question.
Exactly, we did exactly that. We found the most relevant car to our questions, and then we said, find us the relationship to this car, two relationships from this relevant car.
Okay, yeah. So you define the part where you kind of retrieve the stuff that you need.
Exactly.
Yeah.
So we have another question. Sorry, Ante, do you want to say anything else on that?
I just wanted to say that query is very generic. It doesn't depend on the graph structure.
Okay, we have the following question. So Dario says, I saw that you uploaded an image that is already in the database, but you retrieve the same image, but the similarity is only 0.65. So what is impacting? He supposes that it should be 1, as it's the same image. Can you maybe, Dino, see what's happening there? Or
yeah, actually, it is similarity is 100%.
Oh yeah,
so it is 1.
The distance. So distance is a metric that define like how far are the other vectors from the So there is like two results here, the distance and similarity, and those are the different metrics. And the distance in 0 in this case is this perfectly aligned, and the similarity is 1 because, yeah, same answer.
Exactly. This is probably the same car, but from another angle. So this one is 0.7. In
Yeah,
real
quite
world
similar, but not
application,
one. Yeah.
yeah, in real world application, we usually use like everything that is above 0.8% similarity, because otherwise you sometimes get some irrelevant results.
And when talking about real world applications, like this is a really cool demo, it has the pictures of cars and so on. But what are your thoughts on that? Like how to utilize these tools that you have used here, all of the LLMs, vector search, and everything that you use here? Like how can that be utilized and graph databases in some maybe business and larger use cases?
When we talk about the application, so when I talked about the image gallery on the iPhones, so essentially they're using something similar where you index and say, okay, this is the person Peter, and then everything related to Peter will be the images that are related to Peter. But like now answering the part like how this can be used with the graph. So if you have like a bunch of images that are just kind of coming to you, and you're extracting some structure from that images, like Dina and I did with this car as a part of POC, so you can kind of see and understand what are the key information from those images, and you can build this knowledge graph. And then this will allow you to see how the images are correlated together, not just by a text that is like that is a descriptor, but rather by some properties that are important to you. So if you are doing a recommendation on all the yellow cars, you can kind of continue that recommendation system based on the yellow pickup truck that you search for example, or something like that. So there are possibilities. I guess the different things can be built with different data engines, not only with the graphs. But yeah, this was an experiment.
Thank you. And do you
Yeah,
have like, can you share this? Sorry, Dino, can you share maybe is it okay to share this code, your demo,
of
to the
course.
audience? Yeah, I have the link here, so I'll share it. Dino, please wrap up what you wanted to say.
I
I
also
jumped in.
saw when I started doing these things, I also saw it in real world applications like Amazon. Amazon has exactly this. You can take a photo of anything in your house, for example, a table, and it will recommend you similar tables with similar colors and so on.
Mhm.
So this is widely used and especially in web shops.
Yeah, yeah, cool. Well, thank you guys. I mean, thank you for answering the questions and thank you for the presentations. Let me just check to not miss anything. Okay, we have another one. So I'm coming from a relational database background. How do you handle temporal data, for example? How do you show the Acura model has changed over the years?
Yeah, so temporal data in graph can have like a date of expiry where you just detach or kill a node, or you decide that that part of the record is maybe not relevant to you, or you kind of build a filter around that you don't want to show the records that are not relevant. So essentially, the graph supports temporal data, and by it, you could technically build in a filter that just takes that temporal aspect into the result. So, for example, Dino could ask, like, give me the cars that are from the 80s, and again, if the knowledge graph had like the temporal aspect of it, and it was connected by the generations of car, it could kind of properly fetch that. But that needs to be built in. We didn't build it for this demo purpose.
Thank you. Thank you for answering, Ante. But yeah, regarding that, you can check out on Memgraph docs the temporal data that Ante was talking about, as well as the time to live feature that might be useful in these use cases. So sharing the link in the chat as well. And I think that's it. If there are no other questions coming while I wrap up, again, thank you both for joining and doing the presentation. And the demo was awesome and it worked well. So the demo gods were with you this time. Awesome job, guys. And I hope everyone enjoyed as well. And until the next community call, that's it. Thank you and enjoy the rest of your day.
Thank you for the invite. Ciao.
Bye.
Thank you. Bye bye.